Hello all. If you have not done so already, you should grab a new notes packet off the front table as well as a calculator. So, today we are getting into chapter 7, which focuses in on quadrilaterals and other polygons. Today we're going to be focusing on the polygon piece. So open up your notes packet to page 3, which is the first page with notes. So a polygon is an enclosed shape formed by 3 or more line segments. Now that key thing there is that it is closed and that it is formed by line segments, not curves. All of the sides of a polygon must be straight. Now, when it comes to polygons, there are a couple of different classifications of them. There is concave and convex. Concave essentially means at some point it's caved in. It has an indent in the shape. So like that heart-looking one, lightning bolt-looking one, kind of this cross-looking one, all of them have indents, which makes them concave. On the other hand, convex, that's more typically what you think about when you think about a polygon. All of its corners are going outwards. On the other hand, the moment that you have anything that's curved sides, that makes it not a polygon. Now, when it comes to our polygons, one of the important things that we talk about with them is what's known as a diagonal. And you've probably heard me talk about diagonals. Diagonals are lines that connect two non-consecutive vertices, and they're drawn inside the polygon. Essentially, if I look at, say, this hexagon that's on the far right side of convex polygons, diagonals do this. And I can draw in a lot of different diagonals because there's a lot of them in this shape. There's the obvious ones that go directly across that people tend to think about, but there's also the lesser obvious ones that don't necessarily go perfectly across to the opposite side, but they still connect to a non-consecutive, in other words, a corner not right next to it. And so I can get a lot of diagonals in a shape. The bigger the shape, or the more sides on the shape, the more diagonals. Now, one of the things we do is we classify polygons by their number of sides. In other words, we name them. 3-sided polygon, you should know this one. Triangle. 4-sided polygon, be careful. People often say square or rectangle. Those are specific 4-sided polygons. The more general name, quadrilateral. 5-sided, pentagon. 6-sided, hexagon. And generally, these should sound familiar, at least most of them. Now, when it comes to these shapes, oftentimes we think of the perfect shape. But to be a hexagon, all it needs is to have 6 straight sides. No one said any of those sides had to have a consistent length or a consistent way that they are connected. As long as there are 6, 1, 2, 3, 4, 5, 6, that makes it a hexagon. You don't have to draw all these shapes in. The key thing that I have with this drawing piece is oftentimes we think of shapes like this one, which is an equilateral triangle when we think of a triangle, but you don't have to have the perfect one. The pentagon that they have here is a great example of one that's not perfect. It's not what we would often think of, but it's still a pentagon because it has 1, 2, 3, 4, 5 sides. Okay, continuing with our names. A 7-sided polygon is a heptagon. 8-sided, octagon. That's one people generally know. 9-sided, nonagon. 10-sided is decagon. 11-sided is called a hendecagon. And 12-sided is dodecagon. Now, past that, they don't generally have specific names. There's an oddball one here and there that has been given a specific name, but most of them don't have a specific name beyond 12 sides. Now, one of the things that you are going to be asked to do at times is to name the polygon or to classify the polygon by its number of sides. That means telling me these names. And if it has between 3 and 12 sides, I'm looking for these words. But if it has more than 12 sides, we actually just call it an n-gon, where n is the number of sides. So if it had 13 sides, we would call it a 13-gon. And we'd literally write the number 13 dash gon. Now, unlike all of these other ones, it is impossible to draw an n-gon because you don't know how many sides it has. Can we draw a 13-gon? Yeah, sure. We know it's got 13 sides. But if it's called an n-gon, you're not able to make a picture of it. So, when it comes to these polygons, one of the key things that we are going to be doing is finding the sum. In other words, we're going to add up all of its interior angles. Now, if you are looking for the sum of the interior angles of a convex polygon, it has to be convex, no caved-in corners. To do that, we have this formula, 180 times, in parentheses, n minus 2, where since it's an n-gon, n is the number of sides. So, for example, I've got a picture right here. 1, 2, 3, 4, 5, 6 sides. That makes this a hexagon. In other words, it makes n equal to 6. If I want to find the sum of its interior angles, I just do 180 times 6 minus 2. Now, I highly recommend you do this part first. Just follow your PEMDAS. Could you type 180 parentheses 6 minus 2 close parenthesis into your calculator? Yeah, sure. Can you do 6 minus 2 without a calculator? Yeah. So, 180 times 4 is 720. So, if I add up this angle, oops, I don't want that kind of marking. But if I add up angle 1, angle 2, angle 3, angle 4, angle 5, and angle 6 of this polygon, it will add up to 100 or 720 degrees. So, what's that mean we're going to see today? Some problems we're going to see today are explicitly going to say, calculate the sum of the measures of the interior angles. In other words, use that formula. Sorry about that. Okay, nonagon. First thing you got to do is know how many sides that is. Nonagon, n is 9. How do I know that? I go up here and say, okay, nonagon had 9 sides. Your first page is your friend. So, 180 times 9 minus 2. 9 minus 2 is 7. 180 times 7. I have a calculator for a reason. I don't expect you to do that in your head. I don't do that in my head. 1260. Sometimes they might not give you the name of a shape, or at least not a common name. They'll give you 15gon. In a 15gon, that means there are 15 sides, so n is 15. But you do the exact same thing. 180, 15 minus 2. First thing I do is 15 minus 2, which is 13. 180 times 13, 2340. That is the sum of the interior angles of a 15gon. I am going to pause talking for a little bit. Try out on your own the 23gon and the hexagon. Yes, try it out. It's an easy formula. You can all do it. You do not need to wait for me. You should be doing math right now. Okay, you should have gotten 3,780 for the 23gon. And technically the hexagon we did above, 720. Okay, now there's going to be another type of question you're going to see today. And that is find the value of x, and then it might ask you to find each interior angle. We're going to maybe change that a little bit. But so I see a polygon. The first thing I notice is it gives me all of those interior angles. It gives me something about them. Remember, this little box right here means that angle is 90. Now, if I want to solve for x, if it was a triangle, triangles' angles add up to 180. But this is not a triangle. This has got 4 sides. 1, 2, 3, 4. Making it a quadrilateral. How do I know how much quadrilateral angles they add up to? I have a formula. 180 times 4 minus 2. I start with this formula. So 180 times 2 is 360. That means that the 4 angles of a quadrilateral should add up to 360. Now, notice, quadrilateral, 4 sides, 4 angles. That is true of any polygon. The number of sides it has and the number of angles it has is going to be the same. So make sure you are adding up the correct number of angles to go with that number of sides. So in this case, I should have 4 angles. One of them's X, one of them's 74, one of them's 90, and one of them's 141. I highly, highly, highly recommend you start at an angle and then, move your way around the shape. That helps keep track of which angles you've done, because oftentimes people lose track of angles if they don't go in a specific order. So those 4 angles are going to add up to 360. And from here, I just solve. I start by combining my like terms. Make sure you're paying attention to positives and negatives when you're doing this. In this case, these are all positive. And so I get X plus 305 is equal to 360. Subtract 305, and X will be 55. Now, the instructions say to solve for X and find the measure of each interior angle. Specifically, it wants each missing interior angle, and I'm not going to give you a problem in the homework that asks for every interior angle. It might just ask for one. For example, in this shape, the only angle that we didn't know was this one. Let's call it angle A. Am I going to let you generically call it angle A? In general, no. The shapes in your homework are going to have names already. But since that one's just X, that means the measure of angle A would be just the 55. But essentially, remember, you plug it back in. Y'all know that. If you know what X is and you know what the expression is for that angle, you plug it in. Okay. Question B. What's the first thing you got to figure out with these shapes? I hope you are thinking how many sides it has. Yeah, maybe you were thinking about what the sum of the interior angles is. You're not wrong there. But you need to know how many sides that has. So, you'll notice that when I go around and count sides, I tend to put a dot. I do that so I keep track of where I started and where I ended. Sometimes it's really easy. This one I could look at it and say, okay, it's 5 sides. But especially as they get bigger, it's good to kind of put dots on things. So this is a pentagon. How do I know that? It's got 5 sides, and that's what you call a 5-sided polygon. It's a pentagon. And I do my 180 times 5 minus 2. 180 times n minus 2, where n is the number of sides. That would be 180 times 3, which if I believe is 540. Yep, I mathed right. Go me. Okay, now, especially on ones like this where some of the angles, you'll notice, are the same in different places. You gotta make sure you're adding up the angles and not missing any. So I'm gonna start at 142, and then I like to work my way around clockwise. So the next one would be 2x, 3x plus 14, another 3x plus 14, another 2x. That is 5 angles I added together, which makes sense for a 5-sided polygon, for a pentagon. And guess what? We do the same things. Combine like terms. 2x, 3x, 2x, and 3x is 10x. 142, positive 14, and positive 14 is 170. Subtract 170 from both sides. I get 370, and divide by 10, and x is 37. Now, Questions that I often get. Can x be negative? Yeah. In some problems, it wouldn't make sense. But x can be negative as long as it doesn't make angles negative. This would be an example. Since this is 2x, 2 times a negative number would be negative, and that would be a problem. But you can have negatives. Can I have decimals? Yeah. General rule of thumb, if it's an ugly decimal, you probably did something wrong. But is that guaranteed? No. Ugly decimals could happen. Okay, now, instructions say find the measure of each angle. Again, on your homework, I'm not going to ask you to plug it back into all of them. For the sake of this problem, we're going to plug it back into all of them. Do I need to find the measure of angle J? No, it's 142. It was given to me. K, on the other hand? Yeah. Measure angle K is equal to 2x, so 2 times 37. 2 times 37 is 74. Thankfully, the measure of angle H is the exact same expression, which means it's the same. Measure of angle L, 3 times the 37 plus 14. Put that into my calculator. Measure of angle L is 125. And measure of angle M is the exact same. Okay, we are going to do one more. Start trying C out on your own, and then I'm going to change the instructions at the end because I'm not going to make you find all of these angles. That's a lot. Ugh, sorry. How many sides does it have? Hopefully you counted 7. So 180 times 7 minus 2. 7 minus 2 is? Yeah, 5. Hopefully someone said 5. Otherwise, it's weird that I said yeah. I know, you would be talking to a video, so it's probably weird if you would responded, but work with me here. Work with me. Be careful of where you start. Make sure you know where you start and work your way around the shape. There are 7 angles here. I'm going to start here. Why? Because I can. And then I go clockwise. 2x, 3x, 2x, 4x minus 5, x plus 10, 4x. Add all of them up. Remember, you calculated what they will add up to. I mark the first angle so that I know when I am done. Notice, just like what we did back with triangles, the parentheses, we don't need them. They're only holding on to the degree symbol. Now, if I see something like this, yeah, it's a different story. Some of the parentheses there are unnecessary. The outermost ones, but the inside ones would matter. Okay, combine like terms. Be careful of the positives and negatives. 2x plus 2x is 4x, plus 3x is 7, plus 2 is 9, plus 4 is 13, plus 1 is 14, plus 4 is 18. Sweet, I did that right. I double checked my math. Don't forget the x on that. -5 and -5 is -10. Plus 10 is 0. Do I really need to write plus 0? No. It's just 18x equals 900. Divide by 18, and x is 50. Now, I told you, I'm not going to have you plug it back into all of these. That would be a little much. But what if I said find the measure of angle GFE? Which angle is that? Hint, it's going to be GF or E. Remember, the middle letter is the vertex of the angle. So F is the vertex, and the angle just goes towards G and goes towards E. So measure of angle GFE is the 4x minus 5. But we know x is 50. So that means the measure of angle GFE is 195 degrees. Does it look like 195 degrees? No, it's not drawn to scale. Okay, be amazing for the sub. Today, got a worksheet for you. It is December 2nd. That worksheet will be due on Thursday, which is the 4th, 7.1, worksheet 1. Please do make sure that you're putting your name on your notes packet so I know who to give it back to if it gets lost here. Again, be amazing for the sub.